Hello and welcome to the 12th video in the Introduction to R Workshop series, accompanying videos run by QIMR Berghofer Statistics Unit. Talked about Statistics Unit before. So today we'll be continuing on with a bit of the more programming side of R. Again, this is still the very basic side of programming in R. We will be using the data set we've used previously, that pulse data txt file. If you want to follow along, know where it's saved, so you can set that as your working directory. So as I said before, we'll be continuing the extended programming in R section, specifically section 18.3. This one just looks at how to work with large amounts of data to apply functions in different ways. Similar concepts to what we looked at the last video with for loops, into more efficient ways in R. There are other ways you can do what we're about to do, depending on how you're using R, but this can be common ways and may often be solutions you find online that will help you. And it's good just to get your hands on more programming skills as well if you're interested in that. So we touched on for loops last video, where we are doing this same thing many times to different values or different subsets of data. But that can be a long process, and there can be ways to get this done faster. So for example, last video we were only looking at single values looping across. We could also loop across subsets of a data set. So rather than manually going through a data set and being like, okay, I want to get these descriptive statistics from this subgroup, and then I'm going to do the exact same thing from the next subgroup, and the next thing, the next subgroup. We can write code that says, all right, for each of the groups that we identify, I want this analysis done. And so we're going to look at some functions that help you do that from the apply family of functions, which is in base R. So it's automatically part of normal R when you download it. So the first one is the by function. So it takes a function, and on each subset of the data, it performs that function. Generally, the by function will only print results to the screen for you. So it doesn't make a new data set or anything like that. The output can be saved, but it is structured in a way that's not necessarily designed for using. It's more just designed for printing and seeing. But we can show you a couple of ways to combine into a data frame for use. So let's jump across to RStudio. Okay, so I've already got my data set, some of the things in here. Let's look at by. So it will split the data set into subsets and perform the analysis on each subset. So we can see here over in the help, the documentation for the by function in the help little window on the bottom right here. The by function takes a couple of important arguments. So it takes a data object, which is typically a data frame, though you can do it with other things. There's the indices argument, which describes how it's going to break up the data set. And then also the fun argument, which describes the function that's going to be applied. So let's look up the example we have here. Our first example of by, we're doing it on pulse data. So we're calling the data object that we called in with reads.csv pulse data like we have in other videos. Indices, we're making equal to pulse data.exercise. So we're looking at getting some statistics separately for each group in exercise, which if we remember, exercise is made of moderate, high, and low. So what we're doing is we're getting different values for the people in each group. And now here, we've explicitly made a function rather than just relying on a, just calling a function like normal. We're using R's function syntax, which is a more explicit way of doing things. There's a section in the booklet on how to write a function in R, which might be helpful for this. Generally, if it's a simple function, you can just use the name, but to be explicit here and uncontrolled, I prefer at least to can write out the function, especially if you're doing something a little bit more complicated. What the function here is saying is that whatever we give it, which is we're going to give it pulse data split up by exercise, function of whatever we give it, the function we write is doing the summary of the weight variable of whatever we are giving the function. So if we run that, you can see that it's taken pulse data, has split it up by the exercise variable, which we can see here. The results are presented simply for high, low, and moderate, and it's applied the summary function to the weight variable in each of those groups. So we've got a summary of the weight in each group. So what we can see is that the high exercise group actually has seems to have a slightly higher weight, median and mean, whereas the low and moderate exercise group are a little bit more similar, though with moderate high, more than low. Yeah, that's a quick way to quickly get summary statistics or some other function output per group in a single line of code. Now, of course, this is just printed to the screen for our viewing. What we can do is we can save the output as an object, and we can try and combine it. So what I'm doing here with this line of code is the exact same code, but I'm saving it to the object output. And if I were to print output to the screen again, I'll type it down in the console here. Just why not? So what it's not the exact same code. We're doing the mean this time rather than the summary. So we're just trying the mean of the weight. So this is the mean of the weight in each group. And so once we have that, we can combine the weight, combine the output that is saved in the object output in a couple of different ways. Because currently it's a combination of lots of different things. It's the output specifically from by. But what we can do is we can use cbind and rbind like we've looked at in previous videos. If we do cbind on that output, it combines it all in one column. And if we do rbind, it'll combine it into a single row. So that can be a way that if you're just getting a single value out from your by function and you want to combine the values all together for using for something else, you can quickly do that with cbind and rbind. If there are multiple values, it's a little bit different. You have to be a bit more explicit with what you do. So here for output 2 here, instead of just calculating the mean, we're going to calculate the range using the range function. I'll show you what that does. So we're going to save, this is output 2, and output 2 is the range. So it's the minimum and maximum of weight for each group. And if we wanted to combine that with rbind, so previously with rbind with output, we combined it all into a row for us. If we were to do that with output 2, it wouldn't work the same because the data for each subgroup is not by itself, it's all contained within itself. You can see that it's only giving back that it's numeric in output 2 for high, low, and moderate. But what we can do is we can use the function doCall. And I won't get too much into it, but just as a way to show you that this can be a quick way to fix that if you're in this situation. So we can use doCall, and we're calling rbind on output 2. And that can be a way to combine it differently so that we have all the results together that we want. So what we're essentially doing there is binding at the lower level first and then combining afterwards. So that's the by function. Again, we're moving through this quickly. You have the booklet there with you. We encourage you to do the examples and look up the documentation. So I am moving quickly in this video. But just to reiterate again, the by function performs a function on each subset in a data set. So you give it a data set, you give it some indices to split up the data set, and then you say which function you want. And you can do a simple function, or you can make your own more complicated function. That can be a way to print results quickly from a data set. And then of course, if you want to somehow combine those results, you can. Next is the aggregate function. So the aggregate function will summarize a data set provided, and it'll aggregate the data by some grouping variable. So this can be a good way, for example, to combine replicate data. So if you have replicate values, I'm thinking more probably of biological sciences here. That if you have replicate data and you want to combine the replicates as some logarithmic mean or some other value, the aggregate function will be a really quick way to do that for you. And it does provide a data frame output, which can be useful for the next step in whatever analysis you're doing. So let's jump across back to RStudio and look at the aggregate function. So it provides a function to all the provided variables, separately for each group specified in the list argument. So what we've got here is we've got the data set pulse data. And we're splitting it up by exercise again. So similar to what indices was this time it's by list. So it's the by input, and we also have to provide it as a list object. So list basically means that instead of just the pulse data exercise being a single vector or factor, list will turn it into something a little bit different. Though it looks fairly similar to a factor, it's just a little bit different. That's just how it works. So the function I'm using is the main. And I've got the nr.rm equals true. So that basically means that if for whatever function I'm using, if there are NAs, it will ignore them rather than make the result NA. So if I control enter, I can see here that for each group, which is high, low, and moderate, I've essentially taken the mean of every single variable here. Now this doesn't make sense a lot of the time. So for example, I've taken the mean of all the student IDs in the high, low, and moderate group. It wasn't really useful, but that's what it will do if I give it all the variables possible. It has given me the height and weight for each group, the mean height and weight and the mean age. It can't calculate means for those factor variables like gender, smokes, alcohol, and exercise, but it has given me the mean, pulses, and year value for each exercise group. So for example, if you were in, say, the biological sciences and you had replicate values, and you had a variable describing which sample the replicates came from, and you wanted to summarize the replicates from each sample, your by variable there would be the variable that says which sample it is inside the list function, and then you could use a mean or a geometric mean for the fun input. So to avoid those columns that we don't really want to have a mean for, what we can do is we can specify the specific variables we want. So that can be done in the data set to begin with. So here, rather than doing all of pulse data set, I'm doing pulse data set, and then using square brackets to select just the columns I want by column name. And I'm still splitting by exercise, still calculating the mean and keeping na.rm equals true. So it's going to remove NAs. When I do that, it only is looking at the height, weight, age, and the two pulse variables. So that is the way we can calculate that more easily. Now we can decide subsets or groups by multiple variables. So we don't just have to use one. And this is why this is the main reason why we require a list argument, because we can put multiple values in here to define multiple groups. So here we have exercise and we have year. So it's going to split the data into combinations of year and exercise. So for each year, there'll be 3 exercise groups, and there are 4 years. If we look at just the list input, this list object here that we're creating for the function, we can see that it's considered both factors, and it'll make combinations of that as it does this function. So I'm going to control enter on that line and see here that it's defined, so the two parts that define a group. So there's group 1 and group 2. So we've got the high exercise people from 1993 and their mean, average, height, weight, age, and 2 pulses. The low from 93, the moderate from 93, and then etc. So the aggregate function can be used to summarize variables within a group, and we can define that group by any combination of categorical variables that way. So again, the aggregate function will summarize the data provided, will aggregate the data together by a grouping system that you define, and provide a function and apply a function that you provide to aggregate the data. Now we'll also quickly look at the apply family of functions, which by and aggregate are related to, but apply is the apply functions are a little bit more specific in terms of what they do. These are different functions to apply other specific functions across different types of data. So if you have arrays or lists or different things like that, and you want to apply functions across that object, as opposed to just having a data frame, there are functions that will help you with that. Again, this may not be something you necessarily will use or want to learn, but it's just a way to increase your coding abilities with R and make things potentially a bit more easy for you. Okay, so I've got an object called my matrix. Sorry. And this is what my matrix looks like. It's a very simple matrix, just 6 values, a 3x2 matrix. But what I can do is I can apply a function across that data. So say I want to go across the rows, I can apply to my matrix in the direction across rows, because 1 is for rows, 2 is for columns, the sum variable. And it's calculated the sum of each row. So this is just a quick way if you have a large group of data to get apply functions across it, rows or column wise. Similarly, if we wanted to do the sum of each column, we could apply to my matrix in the second direction, the sum function. So notice here, because sum is a really obvious function already, I don't have to define it as like a fun input. I can just say sum and I will figure out that I want the sum function. Another one that might be of interest to you is lapply, which works on every element of a list. So if I look at what my list2, which is an object I've already got in there is, I can see it was defined here with this code. So my list2 is a list object that has 3 different vectors in each element. And so I can, to each element of the list, I can apply the sum function and also say for length function. Again, this may be useful to you, it may be not, depending on if you end up using lists in any of your data, but it's just a way to show that there's more programming functionality in R than perhaps you were aware of. And it may or may not be useful to you, but it's good to be aware and it's good to practice. So thank you for looking through this video. Do try the activities and exercises in the book and come along to a workshop if you can. Because of course the best way to learn R is by doing R. Thank you very much.